This is question number 3 from March 24, paper 620 and variant 42. This question is about acids, bases, and alkalis. And table shows pH of different aqueous solutions. Now, the first question, the part A, is define the term base. So, what is a base? Now, according to Bronsted-Lowry theory, bases are proton acceptors. Instead, what is meant by the term alkali? Alkalis are water-soluble bases. Alkali is a water-soluble base. Okay. Now, the next part C, is talking about thymophthalate, that is an indicator. Instead, the color of the thymophthalate in sodium hydroxide. Thymophthalate changes its color at high pH, means in highly alkaline condition. So in aqueous sodium hydroxide, we can guess that it should be blue. And in acidic and neutral condition, it is colorless. Thymophthalate has only two changes. Either it is colorless or blue. Blue in base and colorless in acidic and neutral condition. Now question D1. Use the information in table 3.1 to identify the substance with the highest concentration of hydrogen ions. So we should see the table again. In C, in D, you have to observe the table. In table, highest page is for sodium hydroxide, that is 14, calcium hydroxide 10, water 7, that is neutral, ethanoic acid 4, and nitric acid 1. So the lowest pH is 1 for nitric acid. So substance is HNO3. Explanation why you chose this answer: because it has the lowest pH. Okay. Name an indicator which can be used to identify the substance with the highest concentration of hydrogen ions. If we are talking about the concentration of hydrogen ion, then these simple indicators, litmus or phenolphthalein or thymophthalate, these cannot be used. So for that we use universal indicator. Universal indicator. And this universal indicator used to make pH paper. By using universal indicator, we can determine the pH of the solution. So the concentration of hydrogen ions can be determined by using universal indicator. Now part E of the question number 3, complete the equation to show the dissociation of ethanoic acid in aqueous solution. Dissociation of ethanoic acid in aqueous solution, aqueous means there is water. We have to show its dissociation. So we don't need to write water over here. Instead, we will write this reversible arrow because it is a weak acid. And here after dissociation, only this hydrogen is replaceable. So remove the proton from here. and write hydrogen ions along with this. This is aqueous. Next, write the ionic equation which represent a neutralization reaction between an acid and an alkali. In ionic equation, we need only those ions which react. So those two ions are hydrogen ions and hydroxide ions. So hydrogen ions in aqueous form plus hydroxide ion in aqueous form, they react together to produce water. So this is the ionic equation that we use here. We have question number 3. Dilute nitric acid reacts with aqueous calcium hydroxide as shown. 2 moles of nitric acid reacts with 1 mole of calcium hydroxide to yield 1 mole of calcium nitrate aqueous and 2 moles of water. So the given concentration of calcium hydroxide is this, and 20 centimeter cube of this calcium hydroxide was taken, and it reacts with 25 centimeter cube of nitric acid. So calculate the concentration of nitric acid in gram per decimeter cube and use the following step. In first step, you have to calculate the number of moles of calcium hydroxide used. So this is the amount of calcium hydroxide used. So the number of moles are equal to the given concentration multiplied by volume used in decimeter cube. So the concentration is 0.015 mole per decimeter cube, and volume is 20.0 into 10 raised to power minus 3, because it is in centimeter cube. So for converting into decimeter cube, you need to divide it with 1000. So instead of dividing with 1000, I have written here 10 raised to minus 3. Multiplying the concentration with volume, it is 0.0003 moles. You can write it like 3.0 into 10 raised to power minus 4 mole. Now in second step, you have to determine the number of moles of nitric acid when it reacts with calcium hydroxide. So see the ratio from the equation. So from the given equation, we can find it that 2 moles of nitric acid reacts with 1 mole of calcium hydroxide. So it is 2:1, and now we have to calculate the concentration of nitric acid, sorry, number of moles of nitric acid, and the number of moles of calcium hydroxide consumed are here. This is 3.0 into 10 raised to power minus 4. So x is equal to 2 multiplied by, it will go there. So it is 3.0 into 10 raised to power minus 4. So the answer is 6 into 10 raised to power minus 4. And in a better way, you should write it 6.0. Okay. Now you have to calculate the concentration of nitric acid in the next step. So the concentration of nitric acid, we need the volume, and volume is 25 centimeter cube. So the molar concentration of nitric acid is the number of moles into 10 raised to power 10 raised to power minus 4 divided by 25 into 10 raised to power minus 3, because volume must be in decimeter cube. So calculate its answer. Use your calculator. So after calculation, we got that the concentration in mole per decimeter cube is 0.024. Okay, now the next step is to calculate the percentage in gram per decimeter cube. So what is the difference between gram per decimeter cube and mole per decimeter cube? It is the same difference as the difference between the mass and the mole. So if you want to get the mass, you know that mass is equal to number of moles multiplied by MR of the compound. So our compound is nitric acid, and we know the moles in per decimeter cube are 0.0240 into its MR. MR of nitric acid is 1 plus 14 plus 16 threes are 48. So it would be 58, 62, 63. So now calculate it. Use your calculator. So on calculation, we find it 1.512. So we are to write answer in 3 significant figures. So this is 1.51 gram per decimeter cube.